10 liters of incompressible liquid exerts a force of 20 newtons. So 10, about 10 liters, okay, to the Earth's surface, which implies 9.8. What force would 2.3 liters of this liquid exert on the surface of the moon? The gravity, okay, so 2.3 liters, all right. And then, by the way, liters is equivalent to say m cubed, by the way. It's actually a common notation in my knowledge brain. I wonder if they actually just give that to you over here. No, they don't. Liters is cubes. That's basically the same thing. 1.67 meters per second square. You kind of get where we're going. I think we need the kilograms. So MA equal 20 newtons. So if I did 9.8, 20 divided by 9.8 equals the mass of the whole system. So 20 divided by 9.8 equals about 2.0408 kilograms. With that said, we have the meter square. We know kilograms equals density times volume, right? Um, that's the quite the normal definition that we always use in fluid dynamics. So is M. We know that liquid is this is what we're going to use a lot. But first of all, what we need from this is, well, we need a density basically, and density is found by this. And we have the mass divided by 10 equals about 0.20408. That's the density. They did not give us what the liquid was, so this is important. This equals the density, and density is universal. So yeah, if I have a new volume. So we do. We have a new volume of 2.3. So 2.3 multiplied by density equals a new mass. So multiplied by 2.3, which equals 0.469 38 kilograms. That makes sense. Significantly less volume with the same density. We'll create that. And then, oh wait, did I put multiplied by 9.8? I meant to say multiplied by 1.67. That first of all, this is this portion, and multiplied by that is MA moon, which equals about 0.78387751. So that is about B. Atypical question, but still a good one. I love fluid mechanics, so this is going to be a fast one for me. A sliding plate viscometer is used to measure the viscosity of a Newtonian fluid. A force of 20 Newton is applied to keep the top plate moving at a constant velocity of 6 meters per second. What is the viscosity of the fluid? We go to the handbook, we come over here, we look at this and write it down. We have mu, give me my pen. Mu tangent equal viscosity, dv, which is velocity, and dy. But here's the thing, that gives me nothing. The secret is over here, where we said fluid, film, and a linear velocity profile. And if you don't know, this is a profile of that velocity because of how math works if you actually did the simplified Navier-Stokes, but that's not the point of this question. So you don't have to know that. So this can be simplified to velocity divided by delta, and delta is the thickness of the fluid film. And now they gave me force, and tau is defined by force over A, right? So that implies that if I were to change this, I could do force over A mu v over delta, and then force equals mu v a over delta. And I know we're not solving for that, but that's pretty cool to know, right? We're solving for mu. I don't know where my brain went, but alpha delta v a, I think my brain went into La La Land, and then we covered. Anyways, that's how you solve it. So we can see over here, we have 1 millimeter. Just to plug in all the variables now. Went to La La Land. Anyway, 20 multiplied by 1 meter, 1 millimeter, so 1 divided by 1,000 apparently, and divided by what's the oh yeah, this is a mistake. This is supposed to be 5, by the way. I'll be honest, I did this thing and I got the wrong answer earlier. I was wondering why is this whole thing wrong? Well, apparently the previous person that made this, well, made a mistake in the generation apparently somehow. It's supposed to be 5. The original question is 5, and it generated wrong and gave me 6 instead. I don't know how that happened. Doesn't really matter. But anyways, with the 5 meters per second, and then we have 25 multiplied by 50 divided by 10. Oh wait, it's 20 millimeters so there, but it's centimeters here. Ooh, gross. They are mismatching the units over here, which I remember saying gross last time, but I have to say it again because I'm remaking this video. Second time doing this question actually. Um, yeah. Mostly because of the errors of the first one. You know. Anyways, okay. Um, hmm. All right, I get about 0.003, which I'm assuming is rounded up to 4, unless I made a mistake here. But I think they round up probably, or they oh, it's this thing. No, it's 20. Um, they made another mistake. I forgot earlier. I double checked this one too. There's another mistake here they made over here. I forgot to change it. Yeah, yeah. You can tell I looked at this question earlier too. It's supposed to be 25 over here. I don't know why they made the same mistake here, but 25. So yeah, quite a bit of mistakes in their execution of it. But once you figure out the original question, this is now solvable. This is now 0.04. Yeah, it took a while. That's B. Yeah. Yeah, I don't know why the generation was wrong. This is why later on I just take pictures of it instead of actually using a scan like weirdo. I just couldn't deal with that shenanigans anymore. A 2 millimeter inside diameter glass tube is placed in a container of mercury in an angle of 40 degrees is measured as illustrated. The density of the surface of the mercury is 1355. Yes, okay. And the 37.5 times 10 to the negative 2 pascals, respectively. How high does the mercury rise or be depressed in the tube in the result of capillary? Okay, so this is kind of obvious what you're supposed to do. You're supposed to go over here, do capillary rise over here, and just plug into chug. H equal 4 omega cosine beta divided by alpha d. And that's all you have to do. So I think they gave you everything you need, honestly, and it tells you height of the liquid, surface tension, angle, specific weight of the liquid. Specific weight of the liquid is density. With density, you can get specific weight, and diameter of the capillary tube. You got everything. Um, yeah. I don't see anything we didn't get. Yep. Yeah. So we have this. We have 0.2 outside, and we have 9.1 to increase the weight. So H equal 4, and then whatever the tension is, which is 37.5 times 10 to the negative 2, parentheses cosine 40, right? Which is actually, I don't think that's right. Let me read the angle up here. Angle made by the liquid with the wet wall. Okay, that is 90, that is not that. You have to do 180 minus 40. So it's this angle over here. So 180 minus 40 equals 140. So 140 over here divided by whatever is bottom, 37.5 times 10 to the, no, that's wrong. That's the surface tension. Density is 1355 multiplied by 9.8 is specific weight. That decreases the mass and just does, that's not include mass, basically, is what it's saying. And diameter is 2 millimeters, so 2 divided by 100. So that equals whatever that is. So 4 multiplied by 37.5 times 10 to the negative 2. Um, cosine multiplied by cosine, 140, parentheses, 13550, multiplied by 9.8, multiplied by 2, divided by 100, I think. Okay, I get like, I get 4.3. I think I messed up a little bit the sig fig somewhere. Probably did. But that's fine because um, yeah, I think I messed up the sig fig though. Oh, it's 1,000 over here. That's the messed up over here. Because I get 0.0004, and I messed up a 10 somewhere. So I knew it was the right answer because again, number this ABCD, so the numbers were very diverse. So I get now 4326631. Therefore C. C over here, and then we can delete all that. And the next question will be on an open water thermometer is used to measure the pressure in the tank. The tank is half filled with 500 kilograms of liquid chemical that is not miscible in water. Miscible in water. The nanometer tube is filled with liquid chemical. What is the pressure of the relative tank? Well, this is MGH basically. Yeah, there's no we're doing this question over here, and my recommendation for you is read the first. An open water nanometer is used to measure the pressure in the tank. The tank is half filled with 5,000 kilograms of liquid chemicals that's not malleable with water. Okay, the nanometer tube is filled with the liquid chemical. What is the pressure in the tank relative to the atmospheric pressure? Fair enough. Now, I can do it myself. Yeah, definitely. And also, water has a density of 1,000, by the way. Just so you know, if you want to do it in SI units, it's 1,000. And you can check over there. I found where it is over here. So if you want to do like Control F and find it, is over here, like 1,000, like literally. But generally speaking, that's the first thing we have to do is actually not solve for that. We have to find something over here. I mean, I can do it myself, but it's easier just to look over here, and what we need is Bernoulli, by the way, which is how you solve it. But, they give you a simple nanometer. They give you the equation over here, which is wonderful. Thank you. And they give you what P1 and P2 and PO is. It's wonderful. Why not use it? All right. Anyway, PO is the tank, and P2, whatever, you get what I mean. The first thing I'll do here is actually what I have to do is to do mass equal density volume. And we're trying to get density of the chemical, so density C equal m divided by volume is what we need first. And we know density of the water, the air, right? No, density of the water, my apologies. Density of the water is 1,000. 1,000 kilogram per meter cubed. That's like just standard notation that you need. Um, Sorry, I just found another mistake. It's 50,000 again. I did this whole thing earlier, and that was another mistake I found earlier. So, didn't change it all though, so there we go. That's why I'm redoing this section again and again. It's not because I made a mistake this time. It's actually because the scanner made too many mistakes on on it. Anyways, next at least this section at least. This is 6 because there's two, so 10 minus 4 equals 6. So 6 multiplied by r squared pi is this section's volume. That's volume 1. Volume 2 equals basically 4 divided by 3 pi r cubed. And that is equal to 4 divided by 3 pi r3. So pi 2t. So if you add those volume 1 and volume 2, I got about 108.9 or 104 pi over 3 in my calculator. So 108.908. And let me just do this division on my calculator again. Second answer. I get about huh, also actually no, I need to divide it by 2. So the for 50,000 is for division of 2. So whatever that was, so just divide it by 2. So it's multiplied by 2 over here. So that's about 918.2015. So that's beautiful over there. That gives you the clear density. And now you might be asking now, we have all this stuff now. We have density, we have all this. What do we do next? What we do next is use Bernoulli, the all-powerful, all-beloved Bernoulli. The beloved Bernoulli, as people would call it, because as undergrads, that's the one equation that most students like just gravitate towards because they think it's easy when it's not. Because the way the theorem is not as easy as people think. They say they think it's easy, but in reality, if you think about it, there's some conditions that need to be in place for you to use it in real life. So you can't really use it just willy-nilly. But yeah, as an undergrad, you would guess Bernoulli often, like because hey, why not guess Bernoulli on this question, right? Foolishly. So over here, we need this height and that height. So basically, if I remember correctly, it's like P uh, O minus P, this P O, the equation P1. But if you don't remember this, you could just go over here and look up which one will give you the right answer. And this is asking for what's the relative. And relative is more powerful than anything else. So over here, you move this into the other side, basically, and you do equal. Um, really weird that they don't give you which one. Oh, I apologize. We have to use this one apparently. And this is specific, so this means um, density and G. That's a clear thing that they don't, I think they explained to you. So rho 2, basically, and then it's rho 2. Um, wow, okay, that's interesting. I didn't think that was true. Anyway, G multiplied by H2. And you can see over here that P1 is useless. P1 is never used. So minus rho 1 uh, and G in H1. And you might be asking, what is P, what is this, what is that, what is this? Well, first of all, P2, the reason why P2 is in play, it says rho 2, but P2 is the density of the fluid 2. And then we need P1, which is the density of the fluid 1. But here's the thing, the density of fluid 1 is also PO, so that would mean that we have this as a final equation. Um, so it's what was it again? P2 is rho chemical, not chemical, water multiplied by 9.8 by the height of 400 minus 50, whatever that is. And 400 minus 50 equals like 350 in millimeters. So 1000 divide minus something over here, which is rho C, which is multiplied by 9.8 again. Maybe I have to use 9.81 in this case because sometimes they do that. 225 divided by 1000. Depends on how close they are, and they look pretty close. So I'm not sure if just a standard one would work. So I'm just going to be more specific about it. 850 divided by 1000 minus whatever the density C is, 918.2015 multiplied by 9.81 multiplied by division 225 divided by 1000. Note that this is a case where the where you would need to make sure your calculators is working fine. By the way, I remember that your density and everything is checked out fine because technically speaking, this is the one case where this is a minus over here. And minus your multiplication, it cannot save you. Like if you have multiplication in a different sense but didn't scale it properly, you can kind of guess by the digits over here. But in this case, you can't because it's not going to allow you, basically. Comparative to like something like, I don't know, something more simpler. I don't know. Something that's just multiplication and it's A basically. So this one it was A. We move on now to this question. A gravity dam has a cross-section area shown. What is the magnitude of the resultant force per meter acting on the face of the dam? Oh, wow. Okay. This is a question that requires me to go to wait, face of the dam? So this whole face. So the 30 counts too, huh? Um, yeah, okay. Which we can play this game. Honestly, we have to just do this. And wow. The drawing here is so unflatteringly horrible, I must admit. Who the hell designed this thing? Either way, we need to do something. So pressure, right? We take the pressure, we take the centroid actually. The way you do this is actually the centroid, if I remember correctly. And the centroid of a triangle is basically 1 divided by 3. So whatever the dirt mark is usually happens with the flat plate. Um, so for submerging, okay, do they actually have a shortcut here where they give you the whole entire page on it? Ah, here it is. Here's the painful thing. So I will say this right now. We probably need a bunch of stuff from here. So here, I must admit, there's something special about this. The idea is actually projection. That's the one word I'll put down. Basically, what you will do is to MGH rho GH rho GH. I think it's rho GH, right? No, this is not MGH. That's gravity. It is rho GH over here that equals the pressure max, I believe is what it's called. Emoji H because of Bernoulli. Bernoulli. So what you do is row of water is 1,000. I'm not even gonna try to pretend I don't know that anymore because I definitely do. It's 9.8 multiplied by 50, right? With that said, you have about 1,000 multiplied by 9.8 multiplied by 50. That gives you about 490,000. That basically states over here, the max over here is going to be pressurized this way to force this thing. So now what this says is that you have the distribution. And remember, you're only thinking about what's the magnitude of resultant water force, and therefore you only care about force this way. Um, yes, I'm pretty sure that's true. Um, interesting. The equation is in newtons per meter mega. It's not bad, but it does imply that we are getting a unit depth. That is because it's unit depth probably. Now, with that said, we can actually calculate this because we know this is going to be 490,000, and we can get the area of this. So we can do 1/2 because you're asking for the magnitude of the resultant water. So 1/2, we can do 1/2. And why does it keep on doing that to me? Weird. 1/2 area, whatever the area is, and it's per unit length, which is why there's a 1 meter over here continuously. With that said, area times which is going to be 50. It's just going to be 50. Yeah, 50. Length times width, which is length is 50 multiplied by 1 is happening. So then we do 490, comma 000. So we have 1/2 multiplied by 50 multiplied by 49000 half, which equals about 1225000. That's three zeros over here, three zeros over here, about that much. I mean, that is basically equal to F divided by width, because it's force divided by is per unit of width, basically is what I'm is asking. So this is the first one, number one. And then we have to do the total vertical soon. And vertical is a little bit interesting. We'll do that soon, but you can kind of see that we have one of them already. So this is the total force, and because we're only looking at the total resultant, we don't care. So this is going to give me the x direction this way. So it's going to equal 1, 2, comma 2, 2, 2, 5, sorry, 0, comma 0, 0, 0, newtons per meter because of how it's defined. Next up, we'll have what we call what we'll do is the Fy direction. And you're thinking, how in the world do we get the Fy direction, right? I'll show you. I'll show you soon. So here's what we do with the vertical Fy. And this is going back to like basic a long time ago. So you have to get the mass over here, which is basically 30 area, sorry, 30 multiplied by 20 parentheses plus the beginning area over here, because how you do it is rho G volume, if I remember correctly. And because what you're doing is mg. It's the water weight that's going down on this block. So it's basically 20 multiplied by square divided by 2 because that's how it works. Parentheses rho G basically. So if I were to give you this for water, you plug into your calculator 30 multiplied by 20 plus division 20 square divided by 2 parentheses multiplied by 1000 multiplied by 9.8. That's about 7,840, comma 000. Like, yeah. Now you can understand what you're supposed to do. You can square both of these, basically, is what you're going to do to get the resultant of this whole thing. The resultant is equal to 12.2 mega, because I'm sick of doing the 7.8 mega squares too. I'm going to do the mega because I'm kind of sick of doing the big numbers, and I'm getting used to actually doing the smaller numbers, doing this stuff like this. So I get about 14. This gives me about 14.480333149. So that implies this is the answer, C. I'm pretty sure they rounded up or something, probably 9.81 instead. That's probably half of the game plan. They probably put 9.81 instead of this what I gave. So no, that's their choice. My choice is to keep the same consistency of 9.8, but probably gonna bite my ass in the ass later on, so probably don't do that in the future. But that's my choice to do for now because I'm lazy. Anyway, so 6 by 6 by 6, a vented cubic tank is half filled with water. The remaining space is filled with oil, 0.8. What is the total force on one side of the tank? Ah, okay. So half is filled with water, so we have to create something like this profile, like two different profiles for it. Yeah. Anyways, this is the profile I'm going to give it. So we have to do, this is going to be 3. This is going to be 3. And you might be asking, what is SG? So another thing you need to know about this, SG is rho. I believe it, actually, they should give it to you. If they don't give it to you, that's kind of mean. Um, So let's see, SG Pacific Gravity, SG over here. Yeah, they do give it to you. I was about to say row over row water, because row water is 1,000. So here's another thing: if you don't know something, spend time looking at your hand sheet because it might give you the answer genuinely. Because a lot of time it's like, hey, I don't expect you to know this, so they kind of explain to you what these equations mean. And if you're good at interpreting physics, you can figure it out. Is what I'm realizing. So 1,000 parentheses equal this. So get your calculator out. And 0.8 multiplied by 1,000 equals about 800. 800 equals rho. That is about what we're going to do for rho, whatever this is, rho oil, equal about 800. Note that. So the vent cube water is going to be in the top half probably, because that's how usually it works. The water, it really doesn't matter, I guess, because you're going to add them all together. I guess maybe oil's on top. I don't know. According to the description, oil's on top, which makes sense because it won't mix. Yeah, that makes sense. Oil have to be on top. What's the remaining force in one side of the tank? So here's what we're going to have to do. Because we have density here, we're going to do rho GH to over here, max the P1, whatever rho GH is. So 800 multiplied by 9.8 multiplied by 3. And that gives you a max output of 235 20 is equal to oil. So we're going to say P oil, and it's oil. Over here, we have the max for all of it. So this one is going to be P, and it's going to be equal to P1, which is oil, plus low water GH. So you'll see over here that you grab from the previous and do plus 1,000 multiplied by 9.8 multiplied by the height, which is another 3. We have equivalent to that 52920 newtons, basically. With that said, we have that, we have this. Now we have our triangle. We have a triangle and a rectangle. The rectangle is going to be this, and the triangle is going to be this. So you can imagine what you're going to do. You're going to do what we call, if I remember correctly, what you're doing is basically doing the centroid difference, adding two different centroids, which is doing the summation of AI, YI, divided by summation YI, basically, AI, sorry. And I have that memorized now, which is a good thing. But before we do that, we don't need to do any more of that because we are only looking for the total force here. Look, it asks for the total force. So imagine this. And we can get the distance over here, right? And we can get the height over here. So you can imagine the first part will be 235 20 multiplied by 3 divided by 2. So this force over here is 3 over here is about 35280. Nothing serious, nothing big, right? Now, the hard part is this monstrosity over here. So we have 23520 multiplied by 3, and then we have plus whatever this is. So we'll first do this half, which is possible to be done. Um, but that doesn't give me the full answer, basically, is what I'm trying to put down. That'll give you partial answers, and partial answers are good, but we need to get the full answer, basically, is what I'm saying. Let me, but now I realize there's also a face over here. So actually, to tell you the truth, this is actually partially wrong. So you have to think of it as a 3D question. So actually, let me redo this a little bit. So what you're going to do actually is say over here 23520, right? You're going to multiply that by 3 first, okay? And then multiply by 6 again, and then divide by 2. That will give you a force over here instead. Now over here, we need to do the same thing over here. We do the force over here, and then another force over here. So what that means is you're going to do plus whatever this is, so 23520 multiplied by 6 multiplied by 3. That will give you the plus. And then over here is an interesting one. Because we have 5, we're going to 52920 minus 23520 parentheses. And then we're going to be multiplying 3 and 6 and then divided by 2 again. And once you plug it into your calculator, it should be the right answer. So again, you grab your calculator thing. and then you do multiply by 6, multiply by 3, and you do plus calculator thing again. All right, and then you do multiply by 6, multiply by 3. Wait, I forgot to divide by 2 on one of them. So I'm just going to divide the 2 on the second one. And then the last time we're doing unit per unit, but we actually need to multiply by the area. So it's basic policy on this thing. Yeah, projected area is the right term. Yeah. And then you're gonna do plus parentheses. And then it's gonna be 5 minus 2, 3 that, parentheses, multiply by 3, multiply by 6, divided by 2. All right. I get about 8,9,9,640. So kilo, so that's B. It's beautiful B right over there. With that being said, we go to the next question. So, 35 centimeter diameter solid sphere, 4,500 is suspended by a cable as shown. Half of the sphere is in one fluid and the other half another fluid. The other half in sphere is okay. What is the tension on the cable? All right. Okay. I'm assuming this is saying that this is kind of ideal where there is like a force up and force down because of the water displacement on the body and the weight of the fluid matters. That's what I'm assuming. So for example, over here, this thing over here, I'm assuming what's saying is so basically the Archimedes principle, the buoyant force exerted basically is on here. Because it doesn't give me any indication that there is like a mg on the sphere. Oh wait, there's a sphere mg. Oh, I take that back. There is an mg on the sphere, but there's definitely a buoyant force in the sphere too. And it's going to be half of each one. So that's what we're going to do. So what we can do then is basically say W equal 1/2 rho 1g because half is for the half of the sphere because we're just going to do the whole volume of the whole thing and you're going to see me using cross volume and you're going to see me do this a little bit 1/2 rho 1 rho 2 sorry gv like this and now that is a fluid dispersed of the body basically and that is just part of it. There's F buoyant force afterwards and that is what we're going to have to find out assuming that the density is high enough and it won't go down. But before we do that, we need to figure out this first. Get your calculator out and plug and chug, basically, because volume equals 4 divided by 3 pi r cubed, which is given by that. So it's equal to 1 divided by 3 pi, parentheses, 35 divided by 200 cube. So you can imagine this before what we get. Let me just plug and chug. All right. So this is the weight dispersed by the fluid. We have got it, which is going to be equal to the buoyant force. So this is equal to F buoyant. Now we have to figure out the volume out. Now, what we have to do is kind of the hard part. We have to do the cable T. What does that equal? And we have to do summation of force x y equals 0. So we know over here that there's going to be a buoyant force, which is going to be minus 297. Okay. And then we're going to do plus. No, sorry, not no, this is going to be plus buoyant force. The buoyant force is always positive, man. No, positive. It's going up. Wait, doesn't that mean the tension force I'm assuming is also going up? Yes. That makes sense. The buoyant force should be helping, not disturbing. That means mg is left equals 0. So T equal negative 297 plus mg. Whatever mg equals. So minus 297 plus what is m? Rho times volume. So it's like 4500 times the volume, which is 4 divided by 3 pi, parentheses 35 divided by 200 cubed, multiplied by whatever g is, 9.8. Now, as you know, as an engineer, you should be able to know what is 9.8 by now because what is the gravity at that point. Anyways, let's just plug into our calculator and then get our answer. Okay, I get, hmm, hmm, interesting. I get, let me just make sure. I get equal to 693 newtons. So that must be C. Okay, plug into your calculator correctly, please. Your calculator is there to help you. That's probably the biggest mistake you can make. A diameter of a water pipe gradually changes from 5 centimeters at point A to 15 centimeters at the point B. Point A is 5 centimeters lower. The pressure is 700 pascals, as point A is 664 at B. Friction between the water and pipe is negligible. What is it? Oh, this is Q. This is AV equal AV. But before I do this one, and actually that's Bernoulli. This is actually just Bernoulli. Before I do that, I want to check something. Is the Archimedes principle in here? They should really give Archimedes principle too, genuinely. Like they should give every single thing possible. So, they don't do that. Oh well, not my problem right now. We have to deal with this one. So most likely what's going to happen is there's two equations over here. Flow out, and then there's going to be Bernoulli. Yep, and there's no friction, so we don't have to worry about the friction nonsense that I had to deal with earlier. So over here, they even explicitly point at the middle. Oh, that's funny. So my opinion, P plus rho GH. Is there a velocity on this? Yes. Okay. Plus 1/2 mv square equal. This is gonna be one. This is gonna be a, which this is 0, and then a equal PB plus rho B GHB plus 1/2 MBB square. You might be asking why did I do that? Because I'm too lazy to actually write it this way. It's the same equation, just a little bit painful to deal with. I already have the Bernoulli equation memorized. I don't need to know more. So we are gonna get do we know the velocity initially or not? We know the pressure. We don't know the friction. We know the height. So we know what we know is this one, and this one. So we need QA equal QB basically afterwards. So rho A. Uh, by the way, all the densities can go away because the densities are constant. Just so you know, they're constant. Rho 2 AV. Now A B B. We know that's A equal A B V B. That must be true. So this is a diameter pipe. So A is basically equal to pi parentheses 5 divided by 200 square, VA equal pi over 15 divided by 200 square VB. Now we have two equations, two unknowns. Yeah, we can solve it now. But how do you want to solve it? Because VA, oh my God, this question becomes a pain in the ass to solve because it's a polynomial now. God damn it. So what were we looking for? The discharge rate. So get everything in VB form. So let me just write this over here. Pi parentheses divide 5 divided by 200 parentheses cube square equal about that. Okay, I might need to do a ratio over here. So VA equal pi gets deleted, by the way. So, and these actually get deleted too, right? So actually, in reality, it's 15 squared divided by 5 squared by VB, right? Yeah, it's just that. I just realized that. Anyway, yeah. Huh, that's not that bad, actually. That's cool. With that said, we can write this in PA plus 1/2 M. And then we can do, wow, this is going to be 15. Oh, not, oh, this is supposed to be row. My apologies. Um, this is supposed to be row. My apologies. I was about to say that doesn't seem right. Oh, by the way, the rows are all constant, by the way. They're all the same. But row A equal row B, basically is what I'm saying. So, all right, with that said, we can move over here to row. And I'm pretty sure we don't need a G for 1/2, right? No, yeah, we don't need that. We don't need that because mm, interesting that we don't need that. But uh yeah, Bernoulli's equation. That's what I remember. Either way, with that said, we have 15 divided by 4, and then it's going to be VB equal PB, and it's going to be plus rho GH2 HB plus 1/2 rho VB square. So there's a square over here too. So there's definitely a ratio going on over here now. It's starting to build up, and it's actually overcomplicating things now, I guess. Honestly, it's just now a question of plugging these numbers in and figuring it out. So I want to figure out the easiest way to do that, and I think the best way to do it is actually do it this way: minus rho GH, right, B, and then we can do plus 1/2 rho 15 over 5 4, and then we can do uh parentheses plus minus 1 VB squared equals 0. Why I say that is because there's a function in my calculator that allows us to shortcut this. Um, and that should be the right answer. So for example, if I do 700 minus 664, I should get like 36 kilonewtons, so 1000 over here. And then minus by rho GB, HB. So just give me minus whatever the rho is. Rho is what was the row again? Water, 1000. Multiply. Do you want to like, oh, wait. There's a shortcut to this. There's a shortcut. You divide a row over here, and this is a beautiful way. And in a lot of textbooks, they do it this way because it's much more efficient to do it this way. So 36,000, right? Because it's kilopascals divided by 1000. You see, it turns back to 36. But changing back to 36, I can delete this and I can keep everything running. So it's row instead. No, row is gone, sorry. And then G stays over here, GHB plus 1/2 row, no row anymore. And then we can do parentheses 15 divided by 5, 4 minus 1 parentheses VB square. Here, I actually, if I make a mistake here, I actually understand myself because this is uh like a lot of like numbers over here that I didn't clean up. So minus 13. This is the one time I think I would genuinely say, yeah, I should have been cleaner over here. It would have been so much easier if I cleaned up a little bit. Um, 15 divided by 5, I believe. And then it's go to the square root of 4. And they cancel out because they're CM, right? So you don't have to worry about they're messing up everything. All right, I got 40, and then you got divided by I got 13 divided by 13. We might have actually cooked here. Um, yeah, and discharge rate, right? So this doesn't solve anything right now. Yeah, because I don't have the discharge rate right now. Instead, I have this rate over here, which is, oh, I need to square root this also. So I get, okay, so here's what I get. I get over here 40 VB squared equals 0. VB squared equal 13 over 40 and the square root. I get about 0 0.57, 0.0877. With that said, what you do now is basically put that back into here because I need the Q rate on the top, right? So whatever I have right now, that's the velocity. So velocity multiplied by the area over there, which is basically, what is it? What's the area there? 15 divided by 2, 200 because it is centimeters, and then it's going to be squared multiplied by pi, and then multiplied by 1000, which I don't care too much about, and that should give me the answer. I Yeah, that definitely should give me the answer. Um, hmm, let me do that real quick actually, and that gave me the C. So C is the answer. Yeah, all of this needs more space, honestly. Maybe I should probably invest in like a more space-filled board, but that was Bernoulli. Yeah. Okay, what is the hydrodyne radius of the trapezoid of the penujudicial? What are you trying to say to me? What is the hydrodynamic radius of the trapezoid? Hydrodynamic radius, so RH. They should give me a formula for it. If not, well, it's the cross-sectional area divided by the wedge perimeter. I'll be shocked if they don't give me the RH formula here. But no, they should really give me it. Did they really not give me let me check something. Another thing I will say is there's a way to control F radius. And you can look at this and try to find it. And even on the test, they actually have a form like this. Um Here it is. Cross-sectional area and the wedge parameter is dH over 4. This is important for like weird shape, if it's a rectangle or not. And this is definitely just trying to solve for that. So cross-sectional area is like 3 times like getting all of this, like basically, let me just do it. So 5 times 4, right? It's one of them. Plus 3 times 4 is basically you can do it like this. And then the parameter is basically saying 3 plus 5 plus 3 plus 5 plus 5 plus 5 equal what? So 20 plus 12 divided by 3 plus 5 plus 3 plus 5 plus 5 plus 5. That's about equal to something like something. Uh, Wait. Well, that's not the answers. Oh, this doesn't exist. The perimeter is this. These is surface, they don't count. So my apologies. It is delete the end 4. So delete all that. That is about equal to 2.1333 bar. So that's C. I went too far on it. So I want to cut that out, but I will not because I'm too lazy to cut things out right now. All right, the liquid with specific gravity of 0 0.9 is stored in a pressurized, okay, water storage tank. The tank is cylindrical with 10 diameters. The absolute pressure in the tank above this is 200, above the liquid is 200 pascals, kilopascal. What's the velocity of the fluid gushing out over there? What's the initial velocity of the fluid when it's 5 centimeters diameters or 3 meters? Okay, that makes sense. Um, yeah, we can do that one. First of all, the 0 0.9 it means that this is Sg, which means its density of the liquid, which is liquid, L, divided density of the bottom, which is basically water. So 1,000 multiplied density of the liquid. So density of the liquid equals 0 0.9 multiplied by 1,000. So 0 0.9 multiplied by 1,000 equals about 900 kilogram per meter cubed, right? That's kind of factual. Now we're using Bernoulli. Bernoulli is what we're using basically, and then this time we're gonna use the formula that they give because I'm sick of using my formula. And I think their formula is probably fitting. So rho one divided by rho g plus z one v1 squared over 2g equal p2 over rho g plus c squared plus this 2g. And the friction we can just ignore for now. They're not really that valuable right now to us. Really not. And what we're going to do is basically Q in, Q out is no, actually we don't need to do this one. So I think we have all the information, assuming that we use the velocity of 0 initially. So okay. So we have density equal the liquid equal 900, and that is pretty important over there. Now, where do we choose? The second thing that's important is where do we choose our Z1 and Z2? And the idea, in my opinion, is that we know the pressure over here, so I would choose Z1 as 7. And to make it easier, we can actually delete Z2 by doing the special thing called 7 minus 0 0.5. That's 6.5. So if I choose Z1 equals 6.5, that really gets rid of a lot of the problem. 6.5, yeah. And then we can do plus, and then we know this is pressure, by the way. We know the pressure of 200 times 10 to the 3 divided by whatever liquid. Also, density is all liquid, so it's 900, right? We already discussed why it's 900. And we know the velocity is 0 over here, so we can just do 0 for that. And then the pressure on the outside, that's a good question. What's the pressure on the outside? And in this case, we just have to read it. A liquid storage tank. The the absolute pressure in the tank above the I think if it's a gauge pressure, then it'll be 0. It should be 0 then. And then or almost near 0, so I don't really give a crap. And then it's 2g over here. So here's the thing now. We can now multiply this whole thing by 2g and square root. Now here's the thing. Don't forget about the square root. That will get you. A lot of times the students, me including, forget that and mess up. I've seen it with myself. I've seen it with other people. And it's 900 on the bottom. And then plus 9.5 parentheses. It's a very common issue we have. I don't want you to fall for it too. So there you have it. Don't do that. Anyways, we should be solving this one. So, hmm, I think, well, technically speaking, actually thinking about it, you should do minus p. I think I was wrong. I think this one actually does matter because I'm getting insane numbers. I'm getting something stupid. So I think this is wrong. Let me just recheck it. If that's true, then I have to say, you have to know what the if that's true, then I have to commend you. You have to know what the P2 is, what the what is the pressure to minus. So that means it is actually square root of P of 2g, right? It's multiplied by 2g, right? And parentheses over here, P1 minus P2 divided by over here is going to be G. No, not G. Not just D, density G. My apologies for not realizing it then. I'm wrong. Plus C1. So if that's the case, atmosphere pressure, I need to know atmosphere pressure, and I hate doing this sometimes, but then that means you have to do Control F on your, and you might be asking, I'm not gonna double check some of these stuff, basically. So I'm gonna double check this stuff, but I'm not gonna, what's the right word? Atmosphere. 1 atmosphere. Oh, come on. You're telling me that they don't have like a whole table for like atmosphere? You're joking. You're telling me I have to memorize the atmosphere? No, no, I don't. I refuse to believe it. Pressure. Give me the actual pressure at atmosphere. I know it's like 1.12 times to 5 if it, and I only know that because I haven't memorized it a little bit. You're joking me. I'm gonna have to memorize this, huh? Okay. Well, looks like I'm gonna give it one more thought, one more check. Um, here. So it's in thermodynamics. Okay. So check zero. What? No, that's 100. That doesn't even make sense. What's going on? I just need a conversion for 1 ATM, man. Um, 1 atmosphere pressure. Instead, I'm getting all this. Okay, you're joking. La 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 la. I'm gonna times this by two in the thing. I'm just shocked that they wouldn't give me atmosphere pressure here. They seriously did it. They gave me H. They gave me H, but they don't give me atmosphere pressure. Here. So 0 Celsius. They gave me vapor pressure for water. Um, sure, buddy. Sure. Um, okay, I'm gonna check one more time, and if they're not here, then I found it. It's here. Found it. Atmosphere standard deviation. Let's go. Page fucking 3. Oh my God. I found it. Now do this equation over here. I think I wasted a lot of time with you guys. So now this should give, in theory, by the 101, because I can't think of another reason why my number is like completely insane. Okay. I was thinking it was zero just because I'll be honest, I thought it was zero initially just because basically there's no way they want you to find this 101, but okay, put that into your memorized bucket list because it's definitely one thing to memorize again. Because obviously it's gonna be tested apparently on you really badly. So memorize it and you can get the answer, which is apparently 18, which is answer choice B. But to be clear, I got 18.6388, 666948, basically. Yeah, that was a painful way to live your day today. Water is flowing at 50 meters per second through a 15 centimeter diameter pipe. The pipe turns at 60, makes a 60-degree turn. Okay, interesting, 60-degree turn. So why does it look like a 90-degree turn when it's a 60? Let me look at the original question. Yeah, that's supposed to be 90. And let me check all the other numbers are correct. Other numbers are correct. This just is stupid. You are making my life painful, whoever made this scanner. I think there needs to be a new company that makes scanners because the company a company is a good business because so far the companies that make scanners are garbage. Probably better coding or better I don't know what they call it ML programs would solve that issue. Anyways, with that said, we're gonna go over here. Well, the pipe makes a 90-degree turn as shown. What is the reaction of the water in the z direction of the bend? So here's the thing. There's something called the impulse momentum principle over here, and you can do Control F and find impulse. There's multiple impulse, and generally speaking, this is kind of the momentum principle over here. But generally, first thing is this. So summation of Q2 density 2 V2 minus summation of density 1 V1 equals a force. And here's what I'm going to say Q is. Q is the rate of momentum, blah, 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 blah. But in reality, what is Q? Q is m dot. M dot is basically, if you think about it, it is, what is it called again? Density times area times V. And not always, but sometimes it is that's not true. Instead, it is the density times volume, but that's not usually true. Actually, I take that back. Usually it's not true. V2 minus, there's a Q over here, Q1. Q1, density 1, V1 is what they do. But you can see there's only one out, one in. You can see that over here. So I'm going to make things easy for everyone and do this to it. I'm going to do summation of a Q1, a Q2, row 2, V1, V2 minus Q1, row 1, V1. You might be asking, what in the world is Q? Q. I don't see what Q is. There's also this theorem over here that's helpful over here. We're going to be using that a lot. But first thing we'll do is Q. What is Q? Um, this is not the Q. It's actually just AV, to tell you the truth. It's all the way at the top over here, AV. I don't know why there's so many different kind of versions of this. Um, I kind of gave up on, you know, explaining all of it, because there's like Q, this is the Q for volume flow rate, but there's a Q over here that's for they don't use this. They use the same thing. This is Q is in terms of pressure drop, the equation for Q, which is a Q out. There's a Q over here. That's the main equation. Q is a discharge, which is they're all the same thing, but they have different equations. So you have to be like kind of smart about it. There's also this equation, which is the overflow sphere atmosphere, and there is a submerge. So there's like different equations. You just have to figure out which one's which and which one we're supposed to use. And I'm just like, what a pain. But anyways, when people complaining about this, we're going to be complaining about it for hours. And the problem is images is not that great. All the images are awful. These images are like half of them, like I don't know who the hell made them, but they need to be fired. Anyways, with that being said, we have this formula over here. Now you can imagine over here that it is basically, well, the vectors are, you know, um very directional. So what that means is you can imagine if it's the z direction, right? All the water flow here is coming because we only need a z. So these vectors over here, v2 and v1. So imagine v2 is like 50 water flow. Over here is v1 that's flowing at another 50. So we have something like in this vector 2, something like if this was x, y, and z, 0, 0, 50, like this. A2, v2, rho 2, minus a1, v1, rho 1, uh, is 50, 0, 0. So you can kind of see the problematic situation we're having over here. I'm basically saying that one of them doesn't have any agency to the velocity. But here's another thing I will say. Q is the volumetric. So actually we can we can erase this and put like V bar over here and V bar over here instead. Because there's a vec if that's not a if that is not a magnitude at this point and it makes a Q over here, well, the problem is basically the tensors don't line up. So there's also that you have to deal with. So it's actually VA by VA, kind of a little confusing. But as you can see, in one way or another, I don't need to explain anymore. I keep on trying to explain all this stuff. Just know that it is basically this. That will give you the answer because that's how it works. I'm trying to explain all these tensor nonsense shenanigans. Why am I doing that? Just solve it. I need to stop doing the overcomplicated explanation. So it's divided by 2 because it's a diameter. So in its parentheses, and then it's a power to square. So it's del, and it's a square to a 2. And it's going to be multiplied by 1,000 because it is definitely one of those equations. Multiplied by 50 square, which is about, I got 44178. So this is equal to saying 44178 newtons. So it's kilonewtons. So it's like 44 kilonewtons. So, oh, it's one of these two. Wow. I need to actually figure this out. Well, this velocity is going this way. We can imagine this is going this way, right? So I mean I got positive, so I'm assuming it's positive. D. You could argue it might not be positive, but I'm assuming that the math of how this works is correct, which it says over here Q2 is the rate of flow leaving. So if this is leaving, I'm sure that what is the reaction of the water in the z direction is bed. Wait, what is the reaction on the water in the, oh, it's obviously 44 because we're not talking about the pipe. The pipe would be the opposite, but you can't really create a force like that. So this is correct. Took a long time for me to just realize it, but got it in the end. Over here next is the density of the airflow in the duct is 1.15 kilogram per meter square. Okay. All right. And the pivot is placed on the shown. The static pressure in the duct is a wall tape, and the gauge is determined by the velocity. Okay. I don't have enough information to do anything. Let me look at the original equation. It probably got cut off somewhere. What? That is the original question. Really? That's enough to get something? What do you mean? There's nothing in the information bank. I can't get anything with that. The static pressure in the duct is measured by the wall tap. Oh, okay. I can't get anything with that because this images is totally wrong. Uh, I can't read that shit. Let me just redo it because they are killing my ass. And I'm just gonna point at this and just gonna give you what they're supposed to be. They're supposed to be, I mean, if you can read that, 6. Yeah, I don't think anyone could read that. Yeah, again, I need to get a better software for the scanner. I'm not getting the best deal for this. Um, obviously. But look at the quality of this one. Like that's 5.7. No, these quality control people need to make a new scanning app with ML technology. Um, anyways, finally doing 12, and then we're probably almost done with this section. So in this case, we can now do this. We can now do the question at least. Uh, maybe do it like this so we can just see what that is. So 7. Let me just point at that 7 over there. And then let's just make this like this. This is the most goofy shit I've ever done. But there we go. Hopefully that makes sense. Okay. So the static pressure. Okay, there's a way to do this. There's V to 0, but I'm thinking there should be like a shortcut in here because why not? It's the time to find all the shortcuts over here. Might be going the wrong direction although. If not, we can always do it by hand. It's not that difficult because I imagine like this device over here as like it has been used like 100 times. So it has been in airplanes they use it a lot to get the pressure difference in there. But I would imagine that they have it here basically. If they don't have that equation, I can just recreate it. Not a big deal. Really not a big deal. But yeah, it looks like they don't have it. A shame, really. I look for like 5 more seconds. Ah, here it is. No, they do have it. This is called a pipet tube, which is a stagnant pressure. And basically, this is the formula. And yeah, beautiful. So it is V equals square root of 2G parentheses PO minus PS parentheses rho G. And that is how you do it. And you can see PO is over here. That's correct. And then PS is over here, and then V is over here. That makes sense. That's correct. And this over here is just extra. That's not really needed for this case, but you can see that it's 7, which is definitely going to be indicating of that. So we can do square root of 2. We can do delete that and do rho parentheses PO is in the center hole, which is 7 times 10 to the 3 minus 6 times 10 to the 2. 3, sorry. And that equals V, whatever that is. Yeah. This is a classic aerospace question. Actually, a lot of aerospace engineers have done this before. Anyways, it was 1.15 apparently. I hope that I mean, they're not going to be nice and do that for every question, really not. But because it turns out some of the questions you kind of have to memorize in the FE exam. So, that's not nice, but I guess they don't really care about us. 71.70288. I guess they want more fails so they can get money again. Think about it, they get more money, but they allow people to pass just because if no one passes, then then no one will pay them. So I think that's why they do that. That would make perfect sense to me how they operate. But then again, it's mechanical engineering where 70% pass. Anyways, water flows out of the tank at 12.5 meters per second from the orifice located over here, 9 meters below the surface. Ooh, okay. The cross-sectional area of the orifice is 0.002, and the coefficient of discharge is that. What's the diameter of the Werner contract? That that Vienta contract, there's no way that there's no like there you go. The contract. I also want to say, hell no, there's no way that the person making this decided not to give a shortcut for this one. Um, Now where is C? Here it is. Um, huh. Now it's definitely one of these. It's probably like one of the sharp edges. No, it's just a flat edge. None of these work. Um, oh, this is troubling actually. Because the Vienna contract usually has some kind of CV you can create, and then you can create the diameter from using the C. Ah, ah, ah. Okay. Hmm. Here's what I'm gonna say about this one. I figured out how to do it. It's bullshit as always, but I don't like it because the way to solve it is not really directly shown in the handout. So you have to look at other sources basically. This is a question that I hope is not in the FE, but if it is, yeah, I couldn't care less about that. I'm just gonna say fuck off. Um, but the how you do it is basically CV equal V over V ideal, which is apparently V equal square root 2GH, and that is from looking at the height difference because over here you can look over here, and it's basically delete that, then the H only appears, and that's the ideal case of it. Ideal case of that happening. So it's CV ideal basically is happening. And if you do CV ideal in this place and do 1.12.5, apparently it equals 0.941 meters per not meters, but that. And then apparently CC is about equal to CV divided by C. So you can imagine that basically CC equals 0.903, and then you do AV vector equal ACA opening, and then do some math, and then you get equal to 0.0181. And then apparently with that, you can do A equal 1 divided by 4 pi d squared and get D equal about 0.05, which gives you D, apparently. Here's the thing I will say, I don't like this question. This question I'm just going to ignore because it's not correct to not have it in the handbook. And if that's the case, this is probably like obscure, like weird question that I couldn't care less about if it's that obscure. Anyway, a nuclear submarine capable of a top water speed of 65 kilometers per hour. How fast would a one-scale model of a submarine have to move to a test pool filled with seawater for similar forces in the submarine and model the dimensional similarities? Okay, so clearly what we have to do is basically do Reynolds number. So, how do I know that? Because there's a moving the test pool filled with seawater, the similarities, and they ask for some kind of force analysis, the similarity, which is internal forces, which is from Reynolds number. So basically what you just have to do is V whatever the length is, which is going to be weird because it's going to be a length of the model for propeller. So P and rho divided by mu, that's Reynolds number, equal V M L rho M divided by mu. And in this case, I don't understand why it makes no sense to me why basically they don't show more. Basically, they don't give me any of the numbers, so I have to figure out myself. So it's VLP divided by LM, right? And we're trying to figure out what's the force of the submarine, dimension similar, and have moving and what how fast. So how fast do you want it? Because that's what you want. So V model equal like mu gets deleted because we're doing same underwater like sea salt bed, whatever. I'll be angry if they make me do the sea salt bed, but you make me actually solve for it, like go to data and figure it out because this question did not give me any of that. And then we have VP basically equal LP. So that's a 1 divided by 20 basically scaling. So it's about 20 about yeah. So basically it's a scaled hmm, interesting. So it's just 20. Hmm. Interesting. I must admit, the speed must be very high for this. I don't like how high this is. So 65 multiplied by 1000 divided by 3600 multiplied by 20 equals about 361.11 D. Now, this question I can understand in the testing area, although I don't agree with it because it's a nuclear submarine, yes, it's capable of top water, speed of 65 and how fast, the submarine, the moving around the test water with the seawater for forces of the submarine. So the only reason I kind of understood that is that there's forces and there's scaling. And if you look at the Reynolds number, that's the only one that can apply to that kind of force. If you look over here, that could only be Reynolds number because it's the force of the internal force of the out viscosity and internal. Oh wait, it could have been other stuff, but it didn't make sense because Ford's number is gravity a little bit. So why would gravity be here? And I don't know what CA is actually. It looks like a Young modulus for some reason. And I don't know what we is. And that's just completely nonsensical bullshit in my opinion. But next question. This one is saying a jet aircraft is flying at 1,700 kilometers per hour. The air temperature is 20 Celsius. The molecular weight of air is 26 grams per mole. So you're going to make me do some molar calculation too. Great. What's the Mach number of the aircraft? Awesome. This is using well, we need C basically, and then we can get V and divide it by C. And then but the hardest part about this is doing R bar. And I hope they give me the formula, or I'm just gonna say what the fuck is wrong with this whole thing. I've been pissed at this thing for a while right now, so um, I haven't been more pissed about something since this section, honestly, because I feel like they're not doing this properly. They should, I don't know, their explanation. Oh, they do this. They do V2 over here. They do show get the ideal. See, you see, like half of this is just finding this shit. Um, half the battle of this whole game is finding shit, which fair enough. I mean, if they want to play that game, they can play that game. I can play that game too, honestly. Okay, and it's taking so long to find this thing. Well, it's supposed to be basically 8.314 or something, and you're supposed to get that basically and divide it by the molar mass. I don't know where it is, but basically you're supposed to do 8.34, and with that 8.34 is I guess another thing to memorize, man. 8.34 divided by 29, and then you have but it has to be in kilo, which I'm questioning if the original question had kilo or not, because at this point there's so many mistakes. No, it's in grams, so I have to multiply this, I have to divide this by 1,000. Um, and then I have to do, that's it. Yeah, that's equals R. And then C, I hope they have the equation for speed, because otherwise I'm just going to be like, well, we have to figure out how to do that. So F, there should be speed, or there should be sound, speed of sound. Like there should be that, shouldn't there be? Like F sound. There we go. C equals square root KRT. That's the important. And let me see if R is given. Where is 8 point? Do I have to really memorize like 8.314? I didn't even memorize. I didn't even write that down properly. What the hell, dude? Like, why do this to me? Like, they should have it here. My God, I'm actually the flabbergasted at half of the decisions they're making over here. Um, Let me go up over here to conversion units over here. Wow, this is going to be just finding things at this point. R bar is in table. Okay, R bar 8.34 over here. Make sure you write that down because gas constant, like seriously, that just pisses me off a little bit. Anyway, I also need to get K for air actually, and I know it's 1.4, but my God, I'm gonna have to memorize that too. Like half of this is just, can you memorize it properly and say it to my face again? Um, yeah. So sound let's just do sound again. K ratio of Pacific heat. Um, Control C, Control F, Pacific heat, Pacific heat, Pacific heat. Do they really not have Pacific heat ratios down here? You're trolling me now. Honestly, what? So you're telling me that I have to memorize 1.4. I already knew 1.4 because I use it so often. But seriously, I'm shocked that there's no table, there's no nothing, there's no CP. Let's just do specific then. There should be a table. Looks like I'm memorizing more. Oh, I'm actually really pissed at this question. Um, yeah, I'm gonna do it, but I'm not gonna be happy now. Yeah, one 1.4 multiplied by 8314. By the way, if you didn't know what I'm doing K R bar over 29 and then just times it by the 1,000. So and then we're doing temperature, which is 20, and then I'm gonna this is C, so we need V over C. So that's what we're gonna do right now. I'm just really pissed at this how they set this up. I haven't been this pissed in a long time. The way they're proactively showing this, and also I think we have to memorize this in Kelvin. So we're gonna have to memorize 273. Um, you know what? I'm just realizing why a lot of professors are just emphasizing memorization. It's because of this goddamn test. This 342.9. I guess you could just guess 343 at that point. And then divided by this 1700 multiplied by whatever this is, which is 1000 divided by 3600, which is about wow. Uh Divided by wait, same number? It's pretty much the same. Anyway, divided by 343 basically, which is 4.9 about oh no, sorry, I meant 1.9. 1.38. Okay, 1.38. That's what I get. All right. B. Yeah. All right. I get the right answer. All right, you're good. All right, I'm gonna say this over the end. A lot of this is bullshit. Like 15 bullshit. 14 less bullshit. That's fine. 13 bullshit. Like at least two of the questions were complete garbage in my opinion, and you should not do them.